Hello students and welcome to the lecture. So students, as we know that we are covering the motion and so far we have covered the motion till part 2. Now this is going to be part 3 because the previous lecture was our part 2. I hope that you have revised the previous part 1 and part 2 in the well enough manner before you have come for this lecture. As many times I have told you, this is for your own benefit. Okay. So in this lecture, basically we will talk about the graphical representation of linear motion, relative velocity, projectile motion, circular motion, and at last we will see the summary of all of it. But before starting, as usual, we have our small disclaimer over here. And the disclaimer is like, the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the image. Now, let's begin with the graphical representation of linear motion. The linear motion of a body could be studied with the help of following graphs. First is displacement time graph, velocity time graph, and acceleration time graph. So these are the three types of graphs through which we could understand the linear motion of a body. If we talk about the displacement time graph, in the displacement time graph, the time is taken on the x-axis and the displacement of the body is taken on the y-axis. Okay, like here you can see. On x-axis, you can see there is a time. On y-axis, there is, you can see there is a displacement. Okay, because we're talking about the displacement time graph. From this graph, we could determine the velocity of a body. From the displacement time graph of an object, we could know the nature of motion of the object. Okay, like we are not only able to determine the velocity, but also we are able to determine the nature of motion. Let us consider the following situation to understand it more. First case, if graph is straight line parallel to the time axis, the object is stationary. Like you can see, this is the graph of the object. Now you can see this is on the straight line. Now it is the stationary object. Okay, because it is not moving here and there. This is at the same place. Okay, this is called the stationary. Case 2, if the graph is a straight line inclined to the time axis, the motion is with uniform velocity. Like similarly, you can see this is the uniform velocity. On 1, it is on 10, on 2, 20, 3, 30, 4, 40, 5, 50. Okay, uniformly, the displacement and the time interval are same. The velocity of the body could be obtained by finding the slope of the straight line. Okay, like if you look at the slope, you will find out the velocity of a body. In this case, the displacement is directly proportional to the velocity. Okay. Second is the case 3. If the graph is curved, the object moves with a variable velocity. Okay, like here you can say this is the graph. The graph is curved. Okay, so at 1 it was 10, or 2 it was 20. Then at 3 it was maybe about, if we connected 2.5. At 40 it may be around 2.8 and all, and 50 it will maybe around the same. So now you can say the change in displacement, not distance. The change in displacement is not in accordance with the time interval. Okay, like in the previous one we have seen that was according to it, so that was a uniform motion. Now here, if you are seeing it, what we are getting, this is different displacement with the time interval. So this is the variable velocity. The velocity at any instant could be obtained by finding the slope or gradient of the tangent drawn on the curve at that instant. There is a note. In displacement time graph, if the slope is positive, the body is said to be moving away from the starting point, okay, or reference. But if the slope is negative, the body is said to be returning towards the starting or reference, okay. Now the second one is velocity time graph. In the velocity time graph, the time is taken on the x-axis and the velocity is taken on the y-axis. Since the velocity is the vector quantity, the positive velocity means that the body is moving in a certain direction away from its initial position, and the negative velocity means that the body is moving in the opposite direction, therefore towards the initial position. From the velocity time graph, we could be determined. First is the displacement of a body in a certain time interval. If we use it, then how we could determine the thing. Since velocity into time is equal to displacement, okay, velocity into time is equal to displacement. The area enclosed between the velocity time sketch and x-axis, therefore the time axis, gives the displacement of the body. Then the acceleration of the body. Since acceleration is equal to the ratio of change in velocity and the time taken, therefore the slope of the velocity time sketch gives the acceleration. If the slope is positive, it is accelerated motion, and if the slope is negative, the motion is decelerated, which means if the slope is going upside, this is the accelerated. If the slope is coming downside or negative, the motion is decelerated or the retarded. Now we could consider the following cases. Case 1. If a body is in a motion with uniform velocity, the velocity time graph is straight line parallel to the line axis as showing in a figure. Like here you can see. This is the thing. Case 2. If a body is in the motion with uniform acceleration, the velocity time graph straight line inclined to the time axis, the slope of the lines gives the acceleration. Like this one. Okay. So this is the case 1. If a body is in the motion with uniform velocity, the velocity time graph straight line parallel to the line axis. This is case 2. If the body is in the motion with uniform acceleration, the velocity time graph straight line inclined to the time axis, the slope of the line gives the acceleration like this. Okay. If the motion is with uniform retardation, the velocity time will be a straight line inclined to the time axis with a negative slope. The velocity time graph could never be straight line parallel to the velocity axis because it would mean that velocity is increasing without increasing time. Therefore, acceleration is infinite, which is impossible. Remember what is written down here. The velocity time graph could never be a straight line parallel to the velocity axis, like this one. Okay? Because it will be means velocity is increasing, but the time is not increasing or anything happening to the time. And this is clearly gives us the indication that the acceleration is infinite because acceleration is the change in velocity in respect to the time, right? So when the time has nothing to do with, that automatically makes the acceleration to present it or to appear as a infinite acceleration, and that is impossible. Got it? If the body initially is not at last, but it is moving with some uniform velocity, and then it accelerates. Okay, the velocity time sketch will not start from origin, but will start from the point on the velocity axis corresponding to the initial velocity of the body. Like here you can see. Okay, it is not originating from the origin, but from a point on the velocity axis corresponding to the initial velocity of the body. Case 3. If the body is in motion with variable acceleration, the velocity time graph is a curve like this one. acceleration time graph. In the acceleration time graph, time is taken on the x-axis and the acceleration is taken on the y-axis. Okay. From this graph, we could find the change in speed in a certain interval of time. All right. Their area enclosed between the acceleration time sketch and the time axis gives the change in speed of the body. Let us consider the following cases. First case, if the body is stationary or if it is moving with a uniform velocity, the acceleration is 0. Okay. Second, the acceleration time graph in such a case is a straight line coinciding with the time axis. Case 2, if the velocity of the body in motion increases uniformly with the acceleration is constant. In such a case, the acceleration time graph is straight line parallel to the time axis on the positive acceleration axis. Case 3, if the velocity of body decreases at constant rate, the retardation is constant. The acceleration time graph is a straight line parallel to the time axis on the negative acceleration axis. Case 4, if the velocity of body changes in an irregular manner, the acceleration is variable. The acceleration time graph will then be curved of any shape. Now, what is the relative velocity? When we consider the motion of particle, we assume a fixed point relation to which the given particle is in the motion. Okay. If V's A and V's B are velocities of two bodies related to the earth velocity of B related to A will be given by this V's AB is equal to VB minus V. If two bodies are moving along the same line in the same direction with the velocity VA and VB related to earth, the velocity of B related to A will be given by V's BA is equal to VB minus VA. If the bodies are moving towards or away from each other, as directions of VA and VB are opposite, the velocity of B relative to A will have magnitude. V's B is equal to VB minus VA equal to VB plus VA. Thus, the motion of two bodies related to each other's relation is the difference of velocities of two bodies if they are moving in the same direction and the sum of two velocities if they are moving in opposite direction. Now, what is the projectile motion? If an object is given in an initial velocity in any direction and then allowed to travel freely under gravity, the motion is called the projectile motion. Okay, like this. This is the certain angle, cos theta, you can say. So that's why it's known as the projectile. Okay, it is traveling freely under the gravity. There is no other kind of force acting on it. In case of a projectile motion, it is assumed that acceleration due to the gravity is constant and the effect of air resistance is negligible. Okay, it is assumption. Projectile motion is two-dimensional motion and could be regarded as simultaneous superposition of two motions. One is horizontal with velocity u cos theta and acceleration is equal to 0. And the other vertical with velocity u sin theta and acceleration is minus. Like this is a vertical somewhat, this is the horizontal and then it's again the vertical. Okay. Following terms are used for the projectile motions. Trajectory. It is the path followed by the projectile. The equation of trajectory, like you can say this line you are seeing, this is the trajectory. Because this is the path following by the projectile motion. Y is equal to tan theta x minus 8 by 2 square cos square theta square. This is an equation of the type y is equal to ax minus bx square, which represents a parabola. So the path of a projectile is a parabola. Time of flight t. The total time taken by the projectile to go up and come down to the same level from where it was projected is called the time of flight. Like here you can say, this is the level. Okay. From here it was, you can say launched. Then the time it has taken from reaching this point to this point, but on the same level that will be a time of flight. For example, if you just take as an example, it was launched from origin and it has taken 10 minutes to reach B because O and B are on the same level. Then the time of the flight will be 10 minutes. Got it? The equations of time of flight is times minutes equal to 2t is equal to 2u sin theta by g. Horizontal range. It is the horizontal distance traveled by a body during the time of flight. The equations of un of horizontal range r is u square sin 2 theta by g is equal to u square 2 sin theta cos theta by g. For maximum range, theta is equal to 45 degree. R max equal to u square by g. Therefore, a projectile will have maximum range when it is projected at angle of 45 degree to the horizon. Maximum height h as equal to u square sin square theta by 2g. At the highest point, the projectile possesses velocity only along horizontal direction. Okay, like this you can say. At the highest point of the projectile pipe, the velocity and acceleration are perpendicular to each other. Okay, like this one you can. In a projectile motion, the particle turns to the ground at the same angle and with the same speed with which it was projected. In projectile motion, kinetic energy is maximum at the point of projection or point of reaching the ground and minimum at the highest point. There are two times for which the projectile travels the same vertical distance, and sum of these timing is equal to the total time of flight of projectile. The time of flight, the horizontal range, and the maximum height independent of mass of projectile. Note 1. When the range is maximum, the height h reached by the projectile equal to u square sin square 45 degree by 2g is equal to u square by 4g is equal to r max by 4. The maximum height attained by the projectile is equal to 1/4 of its maximum range. Now, for height h to be maximum, s max equal to u square sin square 90 degree by 2g is equal to u square by 2g. Therefore, a projectile will have height h maximum when it is projected vertically. Therefore, theta is equal to 90 degree. Relation between h max and r max. H max equal to r max by 2. A projectile has the same range at angle of projection. Okay, like this one. Theta and 90 degree minus theta, or 45 degree plus theta and 45 degree minus theta. Now the circular motion. Motion of an object along a circular path is called the circular motion. There is a uniform circular motion. When an object follows a circular path at a constant speed, the motion of the object is called the uniform circular motion. The word uniform refers to the speed which is constant throughout the motion. In circular motion, since the velocity of the object is changing continuously in direction, its direction of motion at an instant is along the tangent to the circle at that instant. The object undergoes the acceleration. Therefore, circular motion is called the accelerated motion. Therefore, circular motion is an accelerated motion. Motion of moon around the earth, motion of satellite around its planet are common example of circular motion. Difference between uniform linear and circular motion. Uniform linear motion or uniform circular motion. The direction of motion does not change. The direction of motion changes continuously. The motion is not accelerated in the uniform linear motion. The motion is accelerated in the uniform circular motion. Now, what is the angular velocity? The angle subtended by the line joining the object from the origin of the circle, like OP. Here you can say this is the origin of the circle in this figure. In unit time interval, delta t is called the angular velocity. It is generally denoted by this W, and W is equal to theta by t. Angular velocity is a vector quantity. Direction is same as that of delta theta. Relation between linear velocity and angular velocity. If t is equal to time period is equal to time taken by the object to complete one revolution, and is equal to frequency is equal to number of revolution in 1 second, then t is equal to 1 by n, or n is equal to 1 by t, or nt is equal to 1. Now it's part for the summary discussion. We have discussed about the displacement time graph, the case 1, case 2, and case 3. Velocity time graph, case 1, case 2, and case 3 also. Acceleration time graph, we had discussed the case 1, case 2, case 3, and case 4. Relative motion we have discussed about. Projectile motion we have discussed. Trajectory we have also discussed. Time of flight, horizontal range, maximum height. In uniform circular motion, we have discussed about angular velocity relation with linear velocity. Comparison of uniform linear and circular motion we have talked about. And with this, we have finished this lecture. It is requested to all of you, kindly revise the facts and figures that all we have discussed in this lecture and keep yourself ready for the next lecture. With this note, let's end this lecture and